Good morning.
Good morning, sir.
Do you have any doubts with respect to last class?
No, sir, not at all.
Is nothing very audible. One second, one second. You're not very audible here. Yeah, can you hear me now?
Yes, sir, I can hear you.
Oh, I can't hear you at all. Just give me one second. I can hear you very faintly. Yeah, that's what's happening. I just connect you to the speakers. Hoping it'll work. Yeah, Lakshmi, can you say something? You can see if you're audible.
Yes, sir, am I audible?
So sorry, you're not audible at all. Yeah,
Sir, actually, I'm using a different device. Maybe that's the problem.
can't hear you one bit. Can't hear you at all. Is your mic volume on low or something?
No, sir.
Sir, can you hear me now?
Much better. Thank you. Yeah, this is much better. Can hear you properly now. Yes. Yeah, so today we will be doing mathematical reasoning. Do you have any doubts with respect to last chapter or something? Yeah, I'm assuming there are no doubts. Let's begin the class then. Okay, now you know what a sentence is, right? Hmm. Now, this is a mathematical statement when the sentence has either one of two outcomes, true or false, and not both. Okay. Hmm. All right. So a sentence is a mathematical statement if it is true or false and not both. So something called imperative sentences. Right? This is like a request or command. So these are not mathematical statements. Then comes inquisitive or interrogative. That is when you ask a question. These are all not mathematical statements. For example, if you say, give me a glass of water, it's a command. You can't say it's true or false. All right. Or if you say, is every set finite? It's a question. Hmm. Okay. The answer is no, but answer is false, but then it's a question. Okay. Then tomorrow is Monday. If you involve variable time, okay, Variable time. Yesterday, today, tomorrow. Okay, if you say tomorrow is Monday, it's not a true statement or a false statement because it depends on today. Is today a Sunday? Okay. So you know what a truth table is?
Yes, I know.
Okay. So for n statements, there will be 2 power n rows. Okay. So A is there, B is there. So you're looking at 4 rows basically. So A can be true or false, while B can be true or false. So this covers all the cases. Okay, this is how you make a truth table. Involve another one C. What happened? There'll be another T here, another F here. Sorry, 2 more T's, 2 more F's. Then TF, 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 like this. And then T, T, F, 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 F. This should cover all the cases. Now, negation of a statement. Right. So if you're looking at a statement A, the negation is this one. Okay, just understand this. This is not implies. I'm just saying A's negation will be like this, not A. If you're looking at truth table, A can be true or false. That time not A will be false or true. Okay. Next comes and nor and statement. So you need two parts here, P and Q. So true, true, false, false, true, false, true, false. So P and Q is represented like this. Okay, this is equivalent to and this will be equivalent to or. All right. So P and Q. True and true is true. True and false is false. False and true is false. False and false is false. Next, if I say P or Q, okay, put it here. P or Q. What will that be? True and true is true. True or false is true. False or true is true. False or false is false. This is false only when both the inputs are false. And this is true only when both the inputs are true. Is this much clear?
Yes,
Yes.
yes.
Okay. Then De Morgan's law. So not of P or Q can be written as not P and not Q. Not of P and Q will be not P or not Q. You guys know this before? De Morgan's law? In set theory, we studied this in another form. A union B dash will be what? A dash intersection B dash. A intersection B, the whole dash is A dash union B dash. This is De Morgan's law. Okay, same thing has been applied here. That's all. Okay, we'll start with the first question. Find the negation. Find negation. Looking for the negation of this. This can be written as, this can be taken as A, this can be taken as B. So A negation union B negation. Okay. Now apply De Morgan's law individually. This becomes negation of negation is that same thing itself, that same statement. Okay. So here it becomes P union intersection Q or P. Okay, this becomes your answer. Any doubts here?
No, sir.
No, sir.
Right. Okay, next question. Okay, what can you say about this? So here, what you do is you're checking if this is logically equivalent to which of these. You draw a truth table. All right. So P will be there, Q will be there, P will be true, true, false, false. Q will be true, false, true, false. Negation P will be false, false, true, true. Negation Q will be false, true, false, true. We're looking for P intersection negation Q union P. Okay, so first we'll find P intersection negation Q. Okay, P intersection negation Q, this and this. So this is false. This is true. This is false. This is false. So you take this as some R. Okay, this part will be R. So R or P is what you're looking for basically. So R is there or P. This or this will be true. This or this will be true. This or this will be false. So this will be false. Okay. So what is this equivalent to? This is equivalent to, look at the truth table. True, true, false, false. True, true, false, false is P. Is there any other true, true, false, false? No. So you can say that this is equivalent to P here. Your doubts, please shoot.
Sir, no doubts.
Okay, thank you. Any doubts? The rest of you, any doubts?
No, sir.
Yeah. Okay. True. And Q are both are true. P is what? True, false, maybe true or false. None. Okay. Please do this question. It's given that this statement is true and Q and R are also both separately true. You have to find if P is true, false, maybe true or false. Given that Q and R are both true, so we'll use all that now first. Okay, P intersection, not Q. Q is true, not Q is false. Or Q is true and R is also true. So true intersection true is true T itself, right? Okay, they're giving that this is true. This entire thing is true. That is what they're saying here. Okay, so Here it's something union some true statement is true. So it doesn't matter what the something is, right? It can be true or false. Because anyway, this will combine with true to become true. We know the whole thing is true. That is what I'm saying. Okay. And these individual parts are true. Q is true, T is true. So here, P, if it is true, what will happen? This will become true. Fine, this whole thing will become true. What if P was false? False and false is false. False or true is true itself. So it doesn't matter if P is true or false. That's why C will be a correct answer. Any doubts here, guys? Do you understand this?
No, sir. Yes, sir.
Okay. Now, what is a tautology? A statement, write the notes, a statement which is always true. Okay, always true for all values of its components. Okay, it's always true for all values of its components. Okay, it's denoted by E. Similarly, there's something called a contradiction. What's a contradiction? It's always false for all values of its components, and it's denoted by C here. Okay, got this? Like in the truth table, and you got this thing as entire true, 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 true. It means that this is a tautology. Okay, understood? If you get this entire thing as false, 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 this will be a contradiction. Got it?
Yes, sir.
Okay. Now, if you have any statement or tautology, it will be what? It will be a tautology. If you have any statement and tautology, what will it be? A statement or contradiction. A statement and contradiction. What will this be? Okay. Guys, can you tell me what you know here? Well, some statement or a true statement will always be a true statement, right? Some statement and a true statement will depend on that some statement. If it's true, it will be true. If it's false, it will be false. So this is equivalent to P. Understanding?
Yes, sir.
Okay. Now, some statement or false will be what? Will depend on that some statement. Some statement and false will be contradiction only. In some statement and contradiction will be a contradiction. Some statement or contradiction will be that statement. Okay. Hope this much is clear. Then associative distributive, you know, right? P or Q will be Q or P. P and Q will be Q and P, like that. Okay, Q and P. Then P, Q, R will be equivalent to P intersection Q or R. Can be written as P intersection Q or P intersection R. You know it's associative, right?
Yes, sir.
Okay. Now, P or not P will be what? Will be tautology. P and not P will be contradiction or fallacy. Same thing. All right. So basically, it means that not a tautology means contradiction. Like opposite of tautology is contradiction. Opposite of contradiction is tautology. Okay, can you simplify this? What will this be? Hmm. Right. P not P will be tautology or anything else. Okay, this is anything else will be tautology itself. So this is equivalent to a tautology. Got this? Got this example?
Yes, sir.
Okay. Implication. If P and Q are any two statements, write the notes. If P and Q are any two statements, then the compound statement, if P, then Q, it's called implication, is called conditional statement or implication. Okay, P and Q are any two statements, then their compound statement, if P, then Q, is called a conditional statement or implication. Okay, like an example is, if ABCD is a parallelogram, then AB equal to CD is an example. So basically, I will write this as P implies Q, where Q means AB equal to CD and P is the statement ABCD is a parallelogram. Okay, guys? It can be like this or P implies Q. Either of these is correct. All right, this means implication. Now, guys, did you understand one-sided arrow? What it means? Hmm?
Yes, sir.
Yes, sir.
Okay. Now, so this is falls under one condition. Okay. This is falls under one condition. What is that condition? This false when P is true and Q is false. So basically, if I say, if it rains, then match will be stopped. Okay. Suppose I say one statement like this: if it rains, then the match will be stopped. Hmm. The only false statement there is, the only way this can be false is if it rains and the match is not stopped. Right? Okay. Like if it doesn't rain, whether the match is stopped or not doesn't make this untrue, right? I just said that if it rains, then the match will be stopped. What I'm saying is false only if when it rains and the match is not stopped. Got it? Hmm? Are you understanding the logic here?
Sir, can you repeat?
Yeah. So just tell me one if statement, right? Hmm? If I study, I will get good marks. Suppose one if statement is there. If I study, I will get good marks. Now, if I don't study and I get good marks, will the statement be false? If I study, I will get good marks, the statement I'm saying. Hmm? And what happens is if I don't study and I get good marks, will the initial statement be false?
No, sir.
No, because I'm saying only if I study, I will get good marks. Okay. So if I don't study and I get good marks also, that doesn't make this false. Right? You have to understand that part. Hmm? So if I study and then I get bad marks, if I study and I don't get good marks, then this is false. Okay. Understood? That's the only condition. Hmm? So here this P implies Q is equivalent to not P or Q. Let me talk about what I'm saying here. So if I draw a truth table here, P and Q, the truth table will explain this entire chapter basically. Right. So P is true, true, false, false. Q is true, false, true, false. Not P is false, false, true, true. not P or Q. What will that come up to? Not P or Q. This or this will be true. This will be false. This will be true. This will be true. So you should understand here that there's only one case where it is false. There's only one case. Rest everything is true. So what is that one case? When P is true and Q is false. Take this.
Yes, sir.
Okay. Right, so it's false only in that condition. When P is true and Q is false. In all other cases, that statement is considered to be true. Okay. Then this question. So I would suggest you remember this, okay? P implies Q is not P or Q. By the end of this class, you should remember this. But yeah, the statement P implies P or Q is A, it's a tautology, B, it's a contradiction, C, neither tautology nor contradiction, D, none. Come on, what do you do here? So P and Q, two statements are there. So you draw truth table, right? True, true, false, false, true, false, true, false. Now, P or Q is what statement? P or Q is true here, true here, true here, false here. Now it's saying that P is implying Q. What does that mean? This is equivalent to? What will this be equivalent to? Not
Sir,
P
negation of P or P.
or P union Q. Okay.
Union.
It's this statement that should come next. Okay, negation of P or P union Q. So, how do you take care of this?
Sir, it will be a tautology.
It'll be a tautology. You can solve it here itself. You can say
Yes, sir.
not P or
Negation
P.
of P or P is a tautology, and then anything that's R with it will be a tautology.
Correct. So, this will be tautology along with anything. That'll be a tautology. Okay. Or what you can do is you can write this as this form. So, not P is here, not P is false, false, true, true. And then, so this you'll call it as A, this will call it as B. This is A or B. Okay. A or B will be what? True, 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 true. That is how you can say you get a tautology. Guys, any doubts here?
So no doubts for me.
Okay, okay. Rest of you? Harish, any doubts?
No, sir.
Yeah.
No doubt, sir.
Okay, okay, okay. All right. Now, negation of an implication. Okay, so basically not P implies Q is equivalent to P and not Q. You know how this came, right? Not P or Q was P implies Q. And then you take the negation of that, it will become P intersection not Q, De Morgan's theorem. All right. This you don't need to remember, just remember the first part. Okay. This you can figure it out. Yeah. So this is always false except when P is true, and Q is false. Okay. Now, Find, actually find negation of the statement. If it rains, then game will be cancelled. Game is cancelled. If it rains, then game is cancelled. Find the negation of the statement. So P is the statement. It rains. Q is the statement. Game is cancelled. Okay. So we are saying P implies Q is negation. We're looking for this. And we know this is P implies not Q. Okay, and what is P? So what is the statement here now? It rains and game is not cancelled. Understood? This is the negation of if it rains, then game is cancelled. So we're saying it will rain and the game is not cancelled. Understood how I converted the statement? To its negation? So this is the
Yes, sir.
opposite of, tell me.
So
So
no
you
doubt,
asked
sir.
me.
I understood. I understood.
Okay. Guys, the rest of you understood this?
So how did you convert negation of P uh, tending to Q to that?
Okay. So we have negation of negation P or Q. This is what we had, right? P implies Q is what?
Okay,
Negation of?
sir. Okay, sir. Got it.
Yeah. So you bring this inside, you get P intersection negation Q. Next is contrapositive. So if you're looking at P implies Q, the contrapositive is not Q implies not P. So contrapositive is basically the same sentence told in a different way. Okay. All right. So I say if it rains, then game will be cancelled. The contrapositive is if the game is not cancelled, it means it did not rain. Understood? So I say if it rains, the game will be cancelled. The contrapositive is if it if the game is not cancelled, it means it did not rain. Right. So just remember this part. Actually, P implies Q's contrapositive will be not Q implies not P. Okay. So what is this equivalent to? Equivalent to not of understood what's happening here? Not of not Q or not P. So this is equivalent to what? Not P or Q, right? So that's the same thing I applied to this part, the second one. Not of the first part or the second part. Following or not? So this can further be written as Q or not P. Okay, you can draw truth table and verify. Like P is here, true, false, false. Q is true, false, Then not P is there, which is true. Sorry, false, false. True, true. Not Q is false, true, false, true. Then we are looking at not Q implying not P. Okay. Not Q implies not P. What is it? So this implies this. So it is true in all other cases except for the case where this is false. Sorry, this is true and this is false, right? For that implication thing, where this is true and this is false. So this is the only case where this is true and this one is false. Rest everywhere else will be true. Okay. Or you can take Q or not P. Q or not P. Combine them together, you get true here, you get false here, you get true here, you get true here. You can see both are the same, right? Lakshmi, are you following?
Yes, sir.
Yes, sir. Yes, sir. I was just seeing the tables.
Okay, okay, okay. But you got the table, right? Like I just wrote the same thing twice, basically. Not
Yes.
Q implies not P. I use the logic. Please understand how to. Now you can use this faster, right? If I say P implies Q, instead of drawing out not P or Q, instead of doing that separately, you can just directly do it, right? You can just find out where P is true and Q is false, mark that as false. Everywhere else, you can mark it as true. Okay. And this is your takeaway also from this. Now, find the contrapositive. Okay, contrapositive of P implies not P and Q. Okay, so there are options here. P implies okay, these are your options. Please begin. We're looking for the contrapositive of this. This means what? Not of not P intersection Q is going to not P. This is the contrapositive. Not Q implies not P that way. Okay. So this becomes what? P implies not P. And this is option D here.
Sir, option B and option D is same, no, sir?
Oh yeah. Yeah. So option B, oh yes. I meant this. Trying to do was draw this. But did you get the logic here?
Yes, sir.
Yes. Okay. Next comes biconditional. Okay. Biconditional. If P and Q are any two statements, write down. If P and Q are any two statements, then the compound statement P, if and only if Q is called its biconditional. P if and only if Q is its biconditional. Okay. So P implies Q, or P goes like this. Okay, this is a biconditional. So this means that is equivalent to and P. Not Q. So this means one thing. So P implies Q and Q implies P. That is what it means. Okay, essentially. Biconditional, this is what it means. P implies Q and comes like this, and Q implies P. Okay, that is what the if and only if condition means. All right.
Yes, sir.
Okay. Now, can you please draw the truth table? P and Q. Please draw truth table before I'm drawing it. P implies Q. I'll call it A. P implies Q is Q implies P. I'll call it B. So A or A and B. Will be what?
Sir, why have you written negation of Q and Q to be the same?
Negation of?
Sir, in the columns Q and negation of Q, you have written the same. This.
Oh, okay. My bad. It's false, true. Confusion. So P implies Q means. I was just looking at this part. So this part is. Now here, A intersection B will be like this. Okay, so this is biconditional statement. So we can try this also. Not P or Q. So not P or Q is true, false, true. P or not Q. P or not Q will be true, false, true. Now I'll call this C, I'll call this D. C and D will be true, false. Okay. So do you notice anything here? That, look, our answer columns will be here. Okay, A intersection B and C intersection D. Both are the same. Okay, for biconditional, both are the same. I'm just verifying both. Both ways of writing it. Now, here, when is it true? It is true when both the inputs are true, right? Or when both the inputs are false. When the two inputs are different, like one is true, other is false, then you will get false. This is biconditional. Got this?
Yes, sir.
When both are true, you will get true. When both are like different, you will get false. Okay, that's the thing about biconditional. Note that down. Everybody got the truth table?
Yes, sir.
Okay. Now, find negation of biconditional. Okay, ABC is an equilateral triangle if and only if it is equiangular. Find the negation of this. So this will be P, and this will be Q. All right, we are given this here, okay, by conditional. So we have to find the negation of this. This means negation of if P then Q, and if Q then P. That becomes not Q. This is what we have. So you take this negation sign inside. It becomes negation of negation P or Q, and or negation of negation Q and P. This further can be written as P or not Q, or P and not Q, or Q and not P. De Morgan's law. Okay. So this can be written, the statement can be written like this. ABC is an equilateral triangle, and this is and. It is not equiangular, or ABC is not an equilateral triangle, and it is equiangular. Understood? This becomes your statement. All right. Following, guys?
Yes, sir.
Right. Then this statement is tautology, contradiction, neither, none. Okay, what about this statement? P intersection Q by conditionally implies not P. Not truth table. Come on, quickly tell me the answer. By condition, you know, right? Both inputs should be true. Okay. So you take P and Q. True, true, false, false. True, false, true, false. Now, not P is here, which is false, false, true, true. And P intersection Q is here, which is true, false, false, false. Now, we are looking for P intersection Q implies not P. Basically, you're checking when are both false, when are both true. Okay, that is the only case that will be true. Rest other cases it will be false when both are different. Okay, so what do you have here? Almost a contradiction, right? You understood how to fill the truth table first?
Sir, can you explain it again?
Yes, yes, yes. So we had P, we had Q, and we have not P here. Okay, we see all of these things. So I draw P, Q, not P here. And then, so this is A, this is D. So I'm writing this as A, biconditional B. Okay, sorry. A biconditional B. This is what I'm doing basically for this. Understood? Okay. So here I took A as P intersection Q. P intersection Q. This implies B here. So when double, not implies, when that biconditional thing is applied, what happens here? Only when both inputs are true or when both inputs are false do we get true. Rest everywhere else will get false. You understood that part for biconditional, right?
Yes, sir.
Okay. So that's all we did here. So the inputs are not P and P intersection Q. So these are the inputs, this column and this column. Okay. So taking these as inputs, I check where both are false at the same time or where both are true at the same time. Both are true at the same time never happens. Both are false at the same time happens once. That is where I put true. Everywhere else I put false. Okay. This is the
Yes, sir.
fastest way of doing this problem. Okay, so which is the answer? A, B, C, or D? Guys, come on quickly.
C, sir.
Option C, obviously, correct. Thank you. Right, then. Okay, what is this? Like same options as above. Same options as above. Tautology, contradiction, neither, none. What do you do here? P will be there. Q will be there. Draw truth table faster. Come on. Not Q becomes false, true, false, true. E implies not Q, which will be the first set of inputs. P implies not Q. How do you check that? It will be false only when the first part is false. So first part is true and the second part is false. Okay. So we look out for that. First part is true, second part is false. Only once here. So that part will be false. Rest everywhere will be true. Okay. So this is the first input into this final answer. And then P and Q will be what? True, false, false, false. Now we are implying the biconditional here. If I take this statement as A and take this as B, okay, what does this become? Check where both are the same. Are both ever the same? No. So all will be false. The answer will be option B, contradiction.
Yes, sir.
Okay. Now, write some notes for the next subtopic. It's called argument and its validity. Okay. An argument is said to be a valid argument. An argument is said to be a valid argument if the conclusion is true. If the conclusion is true, I'm reading off the notes, okay? Please write it down. The conclusion is true whenever all the hypotheses, S1, S2 up till Sn, okay? So the argument is said to be valid argument if the conclusion is true whenever, so the conclusion in bracket put S, okay? Whenever all the hypotheses S1, S2 up till Sn are true. Okay, they are true. Or basically, argument is valid when it is a tautology. Otherwise, it's an invalid argument. So basically, S is the conclusion of the argument. S1, S2, S3 up till Sn are the statements of the argument. Okay. So you say that the argument is true when S1, S2, S3 are all true up till Sn. Okay. They are all true. And this implies that S is also true. Okay. So this must be a tautology. Okay. This here should be a tautology for it to be true. Okay. For any argument, like even in real life, whenever you argue, you check the statements, are they true, and do the statements imply the conclusion? Only if these cases are met. Okay, so whatever input values you put, when the statements imply the conclusion, you say that the argument is valid, right? It is a basic language thing. Okay. Now, so this is the syntax. The hypothesis is here. So these are the hypothesis statements. Okay. S1, S2, S3 up till Sn. The syntax will be like this: S1, S2, S3 up till Sn, and then S. Okay, this is the syntax for the argument. Okay. Now, test the first question. Test the validity of this argument, where S1 is P or Q, S2 not P, and S is Q. Okay, come on, do this. So basically, S1 and S2 implying S should be a tautology. That is what you're looking for. If it's a tautology, it's a valid argument. If it's not a valid argument. That's all. What do you do? Guys, what do you do? The same thing for all questions, guys. Truth table, exactly. Thank you. True, true, false, false, true, false, true, false. Now, we have S1, which is P or Q, which is true, 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 false. And then S2 is not P. What does that come out to? That is false, false, true, true. Okay. Now, S1 and S2. False, false, true, false. Okay. We need, okay, S is Q, which is true, false, true, false. We need S1 and S2 implying S. Okay, so what do you do here? Is there a case where the first one is true, like S1 and S2, where it is true, and the second one is false? So that is where we put false, but this is true. So this is true. Everything else will also be true. So you get this as a tautology. Okay, which means this argument is valid. Doubts here, guys?
No, sir.
Okay, we'll move along to the next question.
Will false to also be true, sir?
No.
By
Yeah.
implication.
Like in implication, right? The first statement is false. Like I told you the example, right? If it rains, then the game will be cancelled. Now, if it doesn't rain, and the game is cancelled, will that statement be false? No, because I said that if it rains, then the game will be cancelled. Okay, so false true is accepted here. Okay, it's only when the first part is true and the second part is false does that implication become false.
Yes.
Okay. Now, examine the validity of this argument, please. We have E implies Q. Okay. Basically, check if this is a tautology. Tell me what you're getting. So, Harish, the topic is actually over. Oh, he left already. Okay. You're taking too much time for this. P implies Q will be false here and true everywhere else. Not Q will be false, true, false, true. Now, whatever is inside the square bracket, this and this is false, 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 true. Now, square bracket implies
Sir, it's a
not.
tautology.
Yeah, so we have not P as false, false, true, true. And we're looking for this implying not P. So we're looking for a case where this is true and this is false. That is, doesn't happen. Everything is true. We have a tautology here. Okay. So argument validity, validation and all, you understood?
Yes, sir.
Okay. Then last topic here, duals. Compound statement S1 and S2 are said to be duals of each other simply by replacing this by this and this by this. Okay, that's it. You get the duals like that. All right. Now, I'm going to ask you to find the duals. Okay, this by this is and replace T with C. You can also do that. Both are required to find the duals. Okay. So here, how do you deal with this? How do you find the dual? Don't draw truth table. Okay, when you find the dual, simply replace this. Keep everything else the same. Okay, this will change now. And then this changes. And then this changes. That's it. Got this, guys?
Yes, sir.
This is the dual. Easy, right?
Yes, sir. Yes.
Yes.
Blindly substitute. Okay. P or Q. Contradiction. Okay, what does this come out to? This becomes, the dual becomes, what is the dual?
P and Q or C.
Or T. Replace T with C. Don't forget that. Tautology and
yes.
contradiction should be replaced. Okay. Now, if you see anything or tautology, it is nothing but tautology itself. So the dual is a tautology. Understood? Hmm. Now, what does this become? Dual will be C itself. Here are. Okay, guys, find this down quickly. Find the dual of this.
Sir,
Yes,
I'm
tell me now.
Sir,
C, sir.
You getting? Varun, your voice got muffled. I didn't hear you.
Sir, it will be P and
I didn't hear you again. Sorry. Can you please repeat that?
sir, that P and C. No? Like that.
P and C.
Sir,
Or R.
that. Oh, there will be C only.
Okay, so P or C will be what? P or C? That will be P.
P.
Yes, sir, P or C is P.
Sorry. P and C. P and C will be C.
Yes,
Okay.
sir, yes.
P and C will be C. C or R will be R. And this will be a final answer. R will be a final answer.
Yes, sir, yes, sir. Yes.
Okay. And that's it for the chapter. Chapter is done. Okay, so how many more days do we have for the exam?
Not even
10 days.
sir. I have exam on 23rd, sir.
What exam?
JEE.
Oh, your exam is on 23rd. Okay. I got some other exam you'll have on 23rd. No. I was about to tell you to bunk that. So, yeah. Fine then. You have less than a week. All right. How is your integration game?
Sorry, sir.
How is integration for you? Integration for both of you?
Sir, I need some practice in integration, sir.
Okay,
Sir,
that's
even
always
indefinite
good.
is fine, sir. Some definite integrals only. And it's
Definite integrals, you have to apply properties. Once you see definite integrals, know that it will be one like abnormal question. Applying property is what will get you there. Okay.
sir,
So,
like பார்த்தா like NCERT level இல்லையா sir. So it's now I'm not able to indefinite
NCERT
கூட
level has
somehow I'm able
nothing
to
in
get.
it. What?
Sir, like indefinite also actually by looking at the option I'm able to guess how to do it.
Are you differentiating the options?
Sir, no, sir. Like by looking at the
Okay.
option, sometimes like log of some value will be there, so you know that like you have to take the log
Okay.
of
You
this.
know the method to use.
Like,
Like that.
I know which substation to do.
And I am this close away from asking the topic. Like basically, if you have that, if you build that sense, right, with practice, what will happen is indefinite integration, definite integration also when you see, you will apply the correct ways to do it.
Yes,
Okay.
sir.
It's lack of practice, done. Nothing else. No worry. Keep practicing, should improve. Do half an hour of integration every day, man. Yeah, like solve previous year integration problems. That's the best way to go up. You'll know what they ask, what are the methods to learn. Okay. So So integration, area under a curve, and differential equation is what we'll be covering soon. Okay. So I'll be assuming you guys know integration, so we'll be practicing integration last. But
Can
area
you
under
actually do area under a curve, sir? Because actually some questions are tricky. I mean, I was not able to do it quickly.
no, it's not something to do quickly. It's something to do correctly. With practice
Aye.
only, you'll be able to do quickly. Okay.
Aye.
So you have to know what you're doing first, then do it fast. Okay. So don't expect, if you're not very comfortable with it, don't expect to solve it very fast. But you have to learn to solve it correctly. That's the thing. Okay. And there's a lot of visuals involved. So that is how you have to deal with it. Anyway, okay, guys, see you in the next class. All right, you have any other doubts? Please ask now.
No doubt, sir. Thank you, sir.
No, thank you.
Okay, then. Thank you, guys. Take care. All right.